Okay, here we are on our second page. We're going to evaluate all of these inverse trigonometric functions without using a calculator. We might use our unit circle or the finger trick to do these. Let's just get started. I'm going to try to do as many of these as I can. The sine inverse of 1. Sine represents the y-coordinate. The ratio we're given is positive 1. When is the y-coordinate 1 on a unit circle? That would be at here, 0, 1. That corresponds to an angle of positive 90 degrees. Although there are other angles that give you a ratio sine of 1, this is the only one defined by the first page notes. Number 2, the cosine inverse of negative 2. There is a problem with this. The cosine value on a unit circle is the x-coordinate. When is the x-coordinate on a unit circle 2 units away to the left? That never happens. In a unit circle, the maximum value that you could input is an absolute value of 1. Therefore, I do not believe this has some sort of answer to it. The domain says for a cosine inverse, you can feed it any sort of ratio as long as it's between and including negative 1 and 1. This one has no solution. I would go no solution, maybe undefined would also work, but this one can't be evaluated. The tangent inverse of negative 1, the tangent value, let's just review. When we folded our fingers, the number of fingers above the fold, that represents your cosine. The number of fingers below the fold represents the sine. Your tangent value is always opposite over adjacent, or sine divided by cosine. If you haven't watched the video to its fullest, with the finger trick, to find the tangent, you flip your hand over to the back. This puts your opposite over your adjacent. Root 2 over 2 divided by root 2 over 2. That gives us a ratio of tangent equals 1. But the answer isn't 45 because we want the tangent value to be negative. Tangent value is defined between negative 90 and 90, not including those endpoints. So negative 45 would be our answer. At negative 45 degrees, your tangent value would be negative root 2 over 2 divided by positive root 2 over 2, or negative 1. Moving along, number 4, the sine inverse of negative 1/2. Your sine inverse is defined between and including negative 90 and 90. The sine value is negative in quadrant 4, so we're looking for the reference angle to appear in quadrant 4. The sine value is negative 1/2. That means the number of fingers below is 1. That makes 30 degrees my reference angle, but in fourth quadrant, this equals negative 30 degrees. The sine inverse of root 3 over 2, sine is again the y. Sine inverse is defined between negative 90 and 90 degrees inclusive. The sine is the y-coordinate, so the y-coordinate needs to be root 3 over 2. Count up the fingers, 60 degrees. In first quadrant is our reference angle, 60 degrees is our solution. Tangent inverse is negative root 3 over 3. Which is larger, square root of 3 or regular 3? The square root of 3 is less than, the square root of 3 is less than positive 3. Positive 3 is larger than root 3. So we want the larger to be in the bottom. For tangent, I flip my hand over. The larger needs to be in the bottom. At 45, they are the same. The larger in the bottom would mean 1 finger up and 3 fingers down. This is 30 degrees. Now, tangent is defined between negative 90 and 90. So we want the 30 degree angle to represent fourth quadrant, so we're going to say negative 30 degrees. The cosine inverse of 0. When is the x-coordinate 0? Cosine is defined between 0 and 180. The x-coordinate is 0 up here at the point 0, 1. That corresponds to an angle of 90 degrees. Cosine inverse of negative 1/2. Again, cosine is defined between 0 and 180. Negative 1/2. The cosine value of negative 1/2 would represent 60 degrees as a reference angle. 60 in the second quadrant would make 120 degrees our answer. Next one, number 9, the tangent inverse of square root of 3. What is larger, square root of 3 or 1? The square root of 3 is larger, so when I flip my hand over, I need the larger number of fingers to be above the fold. So this is going to represent an angle of 60 degrees because it's positive. Remember, tangent is including angles between negative 90 and 90 without those negative 90 and 90. The sine inverse of negative 2. The sine inverse of negative 2. When is the sine coordinate? When is the y coordinate? Negative 2 units away from 0 in a unit circle? It never is. There is no solution. These are the traditional top 10 questions. At the bottom we have 6 questions where we do compositions of functions. Remember how you evaluate a composition of function? Think back to chapter 3. We always evaluate from the inside out. Here's a combination of traditional trig ratios and their inverses mixed together. Remember, in a traditional ratio, in a traditional trig function, we plug in the angle and it outputs a ratio. In the inverse, we input a ratio and it gives us back an angle. So we're kind of flipping and flopping back and forth. Let's start with the first one. Now, the sine inverse of the sine of 7 pi over 4. 7 pi over 4. Pi is 180 divided by 4 is 45. 7 times 45 is 315 degrees. We're going to start with the inside part. What's the sine of 315 degrees? 315 degrees is in the 4th quadrant. 315 degrees has a reference angle of 45. The sine value in the 4th quadrant is negative. This is negative root 2 over 2. That is just the innermost function evaluated. What we're next going to do is take the sine inverse of negative root 2 over 2. Sine inverse is defined between negative 90 and 90. When is the sine inverse negative? That would be 4th quadrant. And when would it have a square root of 2 over 2 as a ratio? When the reference angle is 45. So the reference angle of 45 in 4th quadrant represents the answer, which is negative 45 degrees. I always want to match the unit of measurement for my angles. If it starts with radians, I need to end up with an answer in radians, is my philosophy. The answer to this is negative pi over 4. I'm going to put a star next to this. How come? This is a little bit concerning to me because I thought inverse functions undo each other. I thought if when you compose any function with its inverse, it gives you back the original input. That is not the case for trig inverses. So this is sort of like an exception. Because 7 pi over 4 is not a valid output angle for the sine inverse, we can't get it back. But we do get something that's equivalent to it. That if you go 7 pi over 4, you end up at a coterminal angle the same as negative pi over 4. That terminal side is the same location. We don't get back the original input, but we get something back that's equivalent to it, or coterminal to it. So that's a little bit different, it's a little bit new. Let's see if we can get these others done. The sine inverse of 1/2 is where we're going to begin. The sine is the y-coordinate, 1/2. This represents 30 degrees. So now the question is, what is the cosine of 30 degrees? The cosine of 30 degrees, using the same fingers, would be square root 3 over 2. And square root 3 over 2 is our answer. Question number 13. We're going to start inside out. The tangent inverse of root 3. Root 3 is a ratio. So I go to the tan side of my hand. Square root of 3 is larger than 1, its denominator. I'll fold down this finger. This finger represents 60 degrees. Next, the problem now reads, what is the sine of 60 degrees? Now I didn't have to adjust the angle because the tangent is positive in the 1st quadrant. The sine of 60 degrees would be square root of 3 divided by 2. So square root of 3 divided by 2 is our answer. Keep moving inside out. Pi radians is 180 degrees. The cosine of pi radians would be the x-coordinate of this point here at 180. That's negative 1. Next, what is the tangent inverse of negative 1? Your ratio of tangent is negative 1 when the tangent angle, so now tangent inverse, now I'm dealing with these quadrants, quadrant 4 and quadrant 1. When is your tangent negative? That would be in quadrant 4. When is it negative 1? When my 45 degrees is my reference angle. I have the same number of top fingers as the same number of the bottom fingers. This to me says negative 45 degrees, but if they give me a radian, I'm going to give it back as a radian. That's sort of like the rule for me. So negative pi over 4. Question number 15. Starting with the inside out, pi over 3 is 60 degrees. 180 divided by 3 is 60. The sine of 60 is root 3 over 2. Now let's find the cosine inverse of root 3 over 2. What angle gives you a cosine value of root 3 over 2? Cosine is defined in quadrant 1 and 2. Root 3 over 2 for the x-coordinate, that would make our answer 30 degrees, but again, we need to convert it to pi over 6. When they give us radians, we give it back. Last one, cosine inverse of root 3 over 2. What is the x-coordinate? Root 3 over 2. That's at 30 degrees. Now, what is the tangent of 30 degrees? This is the traditional way of doing this. 30 degrees is your finger. Tangent is 1 over square root of 3. When you rationalize your denominator, it becomes root 3 over 3. Thus concludes page 2. Please move on to page 3.